Prove that the determinant is independent of theta. Here none of the elements are 0, so we start by expanding the determinant along row 1, that is multiply x sin theta and cos theta from row 1 with its cofactor. On simplification, we find that sin theta cos theta component gets cancelled out and x sin square theta plus x cos square theta can be combined, and we can replace sin square theta plus cos square theta by 1. On further simplification, we are left with only minus x cube, which is independent of theta. Evaluate the determinant. Here we see that in the second row, one element is 0. So we'll do the expansion of determinant along row 2, that is multiply minus sin beta and cos beta with its cofactor. On simplification, we get 4 terms. Each of the terms is a combination of cos and sin with square. Now we can take cos square alpha common from first and third term and sin square alpha common from second and fourth term. We can replace sin square plus cos square by 1, giving us cos square alpha plus sin square alpha. Again, this is equal to 1. Given matrix A inverse and B, find AB inverse. We know that AB inverse can be written as product of B inverse and A inverse. A inverse is already given, so we need to find only B inverse. For B inverse, we'll first find the determinant of B. Here we observe that second row is having one element 0, so we'll do the expansion of determinant along row 2 and we get determinant of B equal to 1. Now we'll find out the cofactors. With cofactors and determinant of B available, we can find the B inverse. Now we will do the multiplication of B inverse and A inverse to get AB inverse. Doing element wise multiplication and simplification, we get AB inverse. Given matrix A, verify that inverse of adjoint of A is equal to adjoint of A inverse and inverse of A inverse is equal to A. From matrix A, we can find out determinant of A by expanding it along row 1 and we get it equal to minus 5, which is not equal to 0. That is A inverse exists. Now we will find out the cofactors of A and substitute it to get adjoint of A. We call this matrix as B. To find inverse of adjoint of A, we have to find the determinant of B. Again, we can expand it along row 1 and we get determinant of B equal to 25, which is not equal to 0. Now we'll find out the cofactors of B. Substituting cofactors and determinant, we can find out B inverse, which is equal to adjoint of A inverse. Here we see that 5 is common within the matrix and there is 1 by 25 outside, so we can cancel it out to get 1 by 5 times a matrix. Now for the right hand side, we have to first find A inverse and we already have the determinant of A and adjoint of A, so we get A inverse. Now we'll find out the adjoint of A inverse by finding the cofactors. Here we see that A inverse had 1 by minus 5 outside the matrix, so when taking the adjoint, it will become square. That means it will become 1 upon 25. Simplifying this, we get the matrix which is same as inverse of adjoint of A. Now for the second question, we have to find out the inverse of A inverse. We already have adjoint of A inverse, so we'll find out the determinant of A inverse, which is equal to minus 1 by 5. Substituting the determinant of A inverse and adjoint of A inverse, we get a matrix which on simplification we observe that it is equal to A. Evaluate the determinant. Here we see that all elements are non-zero, so we can do expansion along any row or any column. We have done the expansion along row 1. On doing the simplification, we observe that all the elements except x cube and y cube gets cancelled out, leaving us with minus 2 x cube plus y cube. Evaluate the determinant. Here we see that all elements are non-zero, but first column is having all elements 1, so we can do expansion of determinant along column 1. On doing simplification, we observe that all the elements except x, y gets cancelled out, hence the determinant is equal to x, y. Solve the system of equations. Here there are 3 equations with 3 variables. So first we'll represent the system of equations in the matrix form, where A is a matrix having all the coefficient, X is the matrix for all the variables. Here we have considered 1 upon X, 1 upon Y and 1 upon Z as variable, and let B be the matrix for the right hand side. So our system of equation becomes Ax is equal to B. To find solution, we have to find out X, which is equal to A inverse of B. For A inverse, first we'll find out the determinant of A, which is equal to 1200. Then we can find out the cofactors of A, and from that we can find out A inverse. Then we can substitute A inverse and B in X is equal to A inverse B. Solving it and simplifying, we get 1 upon 1200 multiplied by matrix of 600, 400 and 240. Now by equality of matrix, we get 1 upon X is equal to 600 by 1200, 1 upon Y is equal to 400 by 1200, 1 upon Z is 240 by 1200, which implies that X is equal to 2, Y equal to 3 and Z is equal to 5. If X, Y and Z are non-zero real number, find the inverse of the diagonal matrix having element X, Y and Z. First we'll find out the determinant of A, which is X, Y, Z. Then we'll find out the adjoint of A, which will again be a diagonal matrix having element Y, Z, X, Z and X, Y. Now we can find out A inverse by plugging determinant of A and adjoint of A in the formula, and we find that it gets simplified to a diagonal matrix having element 1 by X, 1 by Y and 1 by Z, which can also be written as X inverse, Y inverse and Z inverse. Let A be a matrix having 1 and trigonometric function sin theta, where theta belongs to 0 to 2 pi. Then choose the correct answer, where option A is the value of determinant equal to 0 and option B, C and D are the range of determinant of A. So let's first find the determinant of A. On simplification, it becomes 2 plus 2 sin square theta, and now this cannot be equal to 0. So we can eliminate option A. For option B, C and D, we'll find out the range of the determinant of A. Now we know that range of sin square theta is 0 to 1 when theta is between 0 to 2 pi. So range of determinant of A will be 2 plus 2 times of range of sin square theta, which is 2 to 4. Hence the answer is option D.